Good morning to all. We are discussing the topic in theory of computation, that is regular expression. So far, we have discussed the definition of regular expression, how the regular expression is defined, what is the which are the different applications of regular expression, and the identity rules. So these identity rules are nothing but the thumb rules, or we can say that these are the identities, means how the operations on regular expression that can be performed. It is given. It is one can say that it is given with the help of your identity rules. For example, there is the associative rule, there is a multiplicative rule, right? Production rule is there. So if the two regular expressions are there, or the three regular expressions are there, capital P, capital Q, capital R, then suppose if there is a concatenation operation, or if there is a union operation, or if there is a closure operation, which rules, which identity rules we have to follow, that we have discussed already. So in this today's session, we are going to discuss the next topic, right? So first, already discussion has been done on the definition and identities of the regular expression, right? And now we are in this today's lecture session, we are going to discuss the construction of regular expression for the given language. The language is given to you; it is a formal language, and we have to construct the regular expression. And the next one is the construction of a language from the regular expression. A language is given, say, for example, construct a regular expression for the given problem for that particular language. So we have to write a regular expression like, say, for example, a plus b bracket raised to star in this way. And the second point that we have to discuss in the today's session is that we have to construct a language, means we have to define a language regular for the regular expression, means regular expression is given and we have to write the language for that particular regular expression. These are two topics that we are going to discuss in this today's session. So let us see one by one. Construction of regular expression for given language. So here the construction of regular expression is possible using concatenation, clean closure, and positive closure operators, right? So various regular expressions can be understood with the help of problems given here with. So we are going to see various problems. So once we go through all these problems, there are 15 to 20 problems I have listed here. We will go through it one by one so that it will become clear to you. You will get a complete idea how to write a regular expression for a given language, right? So regular expressions generally uses three operators, and it is very simple. It is very simple, and always there is a question in the examination: write a regular expression for a given language, right? So regular expressions generally uses three operators, that is union operator, plus operator, union operator, the concatenation operator, that is nothing but the dot operator, or it is and the closure operator or the star operator. So plus operator is nothing but your or operator. Union means or operator, just like your or gate means A or B, for example. A or B means either appearance of A is there or either occurrence of B is there. While this dot operator, if it is like this, A dot B, if this is the regular expression A, and if B is the regular expression, then plus operator says that is nothing but the union operator, or it is nothing but it is also called as the or operator. Means you are going to union a regular expression A and a regular expression B, means it is or operator, means either A or B. But in case of concatenation dot operator, it is nothing but your and operator. And means compulsory A and B, the occurrence of both expression, regular expression, must be there. That is A dot B, means you can have, if the string is like this AB, it can have AB. AB means the format of string must be in this format, must be in this way. But in case of A plus B, you can have A, or you can have B, or you can have AB. This thing is also possible. Means A means what, you have the zero occurrence of B here. B means what, you have the zero occurrence of A. Getting this point? So remember this point: plus operator is nothing but your union operator, or you can simply, it is called as a or operator, means either A or B. The dot operator or the concatenation operator is nothing but your, this is nothing but your and operator, means the occurrence of the both entities are must, occurrence of the both, whatever may be written on this side A dot B, both are compulsory. And star operator is nothing but your closure property, or it is nothing but the closure operator, means it is nothing but your iteration. It is nothing but iteration. Already we have seen what is the meaning of iteration. Say for example, A raised to star, meaning is that there are zero or more occurrences. Zero occurrence of A means what? Zero occurrence of A means it is epsilon. It is epsilon. One occurrence means A. Two occurrences of A means what? You have to write A, comma A. Three occurrences of A means A. Four occurrences of A A. This is nothing but your, this is nothing but the set. It is called as the set of strings. It is nothing but the set of string of this A star, of this particular regular expression A star. Getting this point? So A is nothing but your regular expression. You are taking it the closure of that particular regular expression. It is called as a star closure, or it is also called as a clean closure. So if I expand this in simple word, I can say that if I expand this regular expression with the star operator, I find here ki, yes, there is a 0 occurrence of A, there is a 1 occurrence of A, there is a 2 occurrences of A, there are 3 occurrences of A, and dot dot dot, so on, right? So while writing the regular expression from a given language, we have to consider, or we have to use these 3 operators, 1, 2, and 3. So without this, there is no any operator. Yes, of course, we have the brackets like your parenthesis, as well as we are going to make use of parenthesis, means curly bracket, as well as our round bracket, or the square, these brackets we are going to use here, right? So clean theorem says that a language can be defined by any one of these 3 ways. Means a language, you can have the transition diagram, you can represent with the help of transition diagram, you can represent with the help of your transition table, or you can represent with the help of a regular expression. Means, say for example, if it is a language L, it can be defined by, that is for example L of R, means language can be defined with the help of regular expression. Suppose if there is a statement that there is the formal language which consists of symbols A and B, having any numbers of A and any number of B. So this is the language. The language consists of a strings. The language which consists of a string having any number of A and any number of B. So this particular language, this is a language you can represent in terms of regular expression. Means you can write a regular expression for any number of A and any number of B. Means I can have this particular regular expression. You can have the transition table for this, and you can have the transition diagram. Say for example Q0 on A, say for example on Q1, and on B. So on B you go to Q2. So I can draw the transition diagram. Transition diagram means you are drawing the finite automata. You are drawing the finite automata for that regular expression. So meaning is that the point of discussion is that the language, remember this thing, language, formal language, it can be represented in terms of your regular expression, it can be represented in terms of your automata, or you can represent in terms of transition table. Getting this point? So let us start solving the example on writing regular expression for the given language. So first one is construct the regular expression for the language containing the strings. Now read the question carefully. Strings as given in the problems. So first problem, or the first example, is write the regular expression for the language accepting all combinations of A over input sigma equal to A, right? So we have to write the regular expression for the language. So language is such that it consists of accepting all the strings having combinations of all combinations of A over input alphabet sigma equal to A. Means this input alphabet contains how many letters? It contains only only one character, that is nothing but your A only. So all combinations of A means what? Yes. So regular expression, this is the answer, are equal to A star. This is nothing but the answer. And if I expand this A star, so I will get here 0 occurrence of A, 1 occurrence of A, 2 occurrences of A, or 3 occurrences of multiple occurrences of A. So my answer to this particular question is R equal to A raised to star. This is the correct answer. So write the regular expression. This A star is my regular expression. R, capital R, I can write here capital R, or I can write here small r equal to A raised to star. This is the answer to this question. Write the regular expression for the language accepting all possible combinations of A over input alphabet is only one here, A. It is exclusively mentioned in the problem. Only input is A, no B is given in the problem. Okay. So second problem, or the second example, write the regular expression for the language accepting all combinations except null string over input sigma equal to A. It is similar to this one, similar to first one, except the null string. Except the null string means except this epsilon, except this epsilon. So all other combinations it accept. All other, it contains all other combination except this particular epsilon sign. So what we have to do here? So you know that it is nothing but your positive closure. It is represented with the help of your positive closure. So I can have R equal to A raised to plus. That is nothing but my positive closure. So are equal to a raised to capital a raised to plus, that is equal to a, excluding your epsilon sign, all other strings contains in that particular positive closure of a. So this is my regular expression for all combination except null string over input sigma equal to a, small a. Next example we'll see here. This is next example. Third example, write the regular expressions for the language containing any number of a's and b's over input equal to a comma b. So here now input consists of two letters a comma b. Input has two letters a comma b, and we have to write the regular expression for the language containing the strings having any number of a and any number of b. So this can be written r equal to a plus b. So any number of a and any number of b means a plus b. So you have to write the expression like this: a plus b means b, you have the two input alphabet, that is a or b. So you have to write here a or b bracket. So a or b means either a or b. This is nothing but your union operator, or it is nothing but your or operator. And to this particular bracket, we are marking here closure. We are marking here closure means multiple occurrences. So multiple occurrences. And as this is a star, as it is a star closure, so epsilon means empty string is there, or the string, it may contain a, or it may contain b, or it may contain double a, it may contain double b, or it may contain ab. This is also possible. Or it may contain ba, or it may contain triple a. So any combination, any number of a means there may be 1a, there may be 2a, there may be 3a, 4a, 5a, number of a's, and 1, 2, 3, 4, 5 number of b's are possible with this regular expression. So remember this by heart. This write the regular expression for the language having the strings or containing the strings having any number of a and any number of b. So regular expression is written. So you have to write answer like this: regular expression is nothing but a plus b bracket raised to star. And if you want to expand, if you want to find out the strings, which are the strings containing this particular expression, so strings written like this: sigma into bracket epsilon, then a, then b, then I have aa, then I have bb, then I can have ab, then I can have ba, then triple a is also possible, triple b is also possible. So dot dot dot, you can have any number of combinations of a and b, any number of a and b are present for this regular expression. So remember this: any number of combination of a and b is the solution. The answer is this one: a plus b bracket raised to star, right? Okay, let us see another example. Write the regular expressions for the language containing any number of a's and any number of b except null string over input alphabet sigma equal to a comma b. The same one, we have to only exclude the epsilon sign. So we have to only exclude epsilon sign means what? What do I have to take here? What will be the expression? How to write the expression here? So excluding this sign means I have to write like this: r equal to, in a plus b, I have to take the positive closure only. It is very simple. I have to take the positive closure. So positive closure excludes your epsilon symbol, right? Okay, so next one is write the regular expression for the language accepting all strings, and these strings are such that they are ending with 0, 0. They are ending with 0, 0 over input alphabet equal to 0, 1. Two input alphabet, and we have to write such a string means the strings are such a way that all the string must end with 0, 0. All string must end with. So read the question carefully. The strings are in such a way that all strings, they must end in a double zero only. So while writing the regular expression, I write here r equal to any combination of 0 and 1 dot. Dot means it is compulsory, dot 0, 0. That particular string must end with 0, 0. So I can write any combination of 0 and 1 means what? Just now we have seen any combination of 1 and 0. It is nothing but your 0 plus 1 bracket raised to star dot 0, 0. Getting this point? So 0 means what you can have? I can have 0, 0, 0, right? Or I can have 1, 0, 0, or I can have 0, 1, 0, 0. This is also, but when you end the string, this particular string must end up with double 0 at the end. This particular string dot, because this is a dot operator and you are taking any combination means this rule you are finding here, this rule you are following here, right? So 0, 1. So 0, 1, if I expand like this, 0 plus 1 bracket raised to star equal to, it has any combination epsilon, then you can have 0, 1, I can have 0, 0, I can have 1, 1, I can have 0, 1, I can have 1, 0, I can have triple 0, I can have triple 1. Okay, so these are the strings containing in 0 plus 1 bracket raised to star. So if I take 0, this first 0, so I can have the string like this, 0.00, or I can, if I take 1, I can have 1.00. This 00 is compulsory. This last 20 is compulsory. If I take this 20, 20.00, then 2111.00, 01.00, or 1010.00 means at the end. So we are fulfilling the condition. We are fulfilling the condition. And which is the condition? So condition given here is write the regular expression for the language such that this particular language, means there is a language which consists all strings, all the strings, they must end up with 00. They must end up with 00. And this is the condition, or this is the regular expression that fulfills, or that is correctly fit for the given problem. Getting this point? So I can write like this: r equal to any combination, because you are concerned, but we are concerned only with the end. We are concerned only with this 20 at the end. But from this onward, we are not, we don't bother about whatever may be the letters. So there may be 0, there may be 0, or there may be 1, or there may be 0, 0, 0, 0, or there may be 0, 1, 0, 1, 0, 1. It may be many letters. There may be any number of letters, any number of characters will be there, but at the end there must be 20. Getting this point or not? So this is the way we have to solve the examples, or we have to write the regular expression. And this is the language. This is nothing but your language. So language is defined. Like how the language is defined? So language is defined. So there is a language L which consists of a string, and these strings end with 00. If I write like this, L equal to, so L is a language in such a way that it contains all strings that end with 00. Right? And for that particular language, I have to write the regular expression. So regular expression means what? So end must be 00, but before this 20, I can have any combination of 0, 1, because why? Because I have the inputs are 0, 1. So there may be any combination of 0. There may be any number of 0 and any number of 1. Getting this point? So that's why this is the regular expression written in this format: 0 plus 1 bracket to star dot 00. Right? So let us go to the next example. Write the regular expression for the language accepting all strings which are starting with 1 and ending with 0 over input sigma equal to 0, 1. Very simple one. Write the regular expressions for the language accepting all strings which are starting with 1. The string must be start with 1 and the string must be end with 0. So very simple. I can have r equal to 1 dot 1 0 plus 1 bracket raised to star dot 0. Means these all the strings, they must start with 1 and they must end with 0. This is correct one. So in between 1 and 0, there may be any combination. There may be any combination of 0, 0, 0, or there may be 1, 1, 1, or there may be 0, 1, or there may be 1, 0, any combination or any number of 1s and 0. But this particular string, this is the string of alphabet that must start with 0, that must start with 1 and it must end with 0. Right? Now let us see the next one. Write the regular expression for the language accepting all strings which are starting and ending with A and having any combination of B's in between. So we have to write a expression for the strings. Now strings, they are in such a way that they start and end with A, starting and ending with A, and have any combination of B in between. So any combination of B in between. So written like this. So means this is start A is compulsory. So when I write A, so this A is compulsory appear in the string. So first A compulsory appear in the string, second A is compulsory appear in the string, and B star. Star means 0 or more than 0 occurrences of B. So I can have AA means it is a 0 occurrence of B. Then I can have ABA, that means 1 occurrence of B. I can have, so strings, these are nothing but the set of strings. These are nothing but the set of strings. So I can have AA, I can have ABA, I can have ABBA, means 2 occurrences of B, but always starts with A and end with A. Then ABBBA means start A, end A, but end with A, and in between 3 B's are there. I can have A, means these many number of strings. This is nothing but the set of strings for this particular regular expression, and it fulfills our condition of the language. So language is such that it consists of all strings. So these are nothing but these all strings which are starting and ending with A and having any combination of B. Any combination means 0 combination, 1 combination, 2, 3, 4, dot dot dot, any possibility is there, right? So let us see next one. Write the regular expression for the language accepting all strings which are beginning with A but not having consecutive B over input sigma equal to A comma B. Okay, so somewhat tricky it is. So write a regular expression. We have to write the regular expression for the language accepting all strings, accepting all the strings which are beginning with A, means beginning must be with A but not have consecutive B's. Consecutive B means what? This string must not contain this BB. The string must not contain the BB means before B there must be A, before B, so A B there must be AB always. Meaning is that if there must not be BB, there must be AB, right? So if we have to avoid this double B, means consecutive B, if we want to avoid it, we have to give the AB, right? So B must not get associated with B, so that's why B must get associated with A only, so that this B will not double B will not appear here, right? So BAB is okay. So BAB is okay because B and these two B are not consecutive here, right? So that's why we take here AB. So we write the equation, right, expression like this: A plus AB raised to star. So combination of this is nothing but your A. There may be A, there may be AB, there may be AAB, there may be AB, A, there may be triple A. So any combination of this is possible, but we are fulfilling the condition given in the problem, given in the example, that yes, it begin with A and it does not have the consecutive B's. It does not have two consecutive B's. Getting this point? Okay, let us go to the next one. It is very simple. It is very simple. There is no such one can say. Just you have to apply your logic. Write the regular expression. Write the regular expressions for the language in which every string here will have any number of A followed by any number of B followed by any number of C. It is very simple. Regular expression R equal to A star dot B star dot C star. The simple regular expression. The language, see, once again, read the question. The language which consists of the strings, and string, there is a fixed format for the string. Now, strings, they are in such a way that it contains any number of A, followed by any number of B, and followed by, so any number means what you have to write, any number means you have to write star, right? And if it is at least, then you have to write down A plus. At least one occurrence of A means yes, this A star gives you one occurrence of A, and any number of A means either it may be 0, it may be 1, it may be 2, it may be 3. Any number of A means you have to write down A closure, means A star. If it is at least one A, then you have to write down the A plus, means at least one A, 1, 2A, 3A, 4A. More than one, it is possible, right? So the string is having combination of A's, number of A's, any number of B's and any number of C's. That means A raised to star dot B raised to star dot C raised to star. So string, can we write the string for this? I can have epsilon means 3 ABCs are missing, ABC are missing, or one occurrences of A, B, C, single occurrence of A, single occurrence of B, and single occurrence of C. The second one string we have formed here. Now A is there, means the B and C are missing. Now I can write B here because A and C are missing here, 0 A and 0 B. I can write C is one string, that means A and B are missing. I can write AB means your C is missing. I can write your BC, A is missing. I can write AC where B is missing. Then I can have a triple. I can have triple A means double A, two occurrences of A, B and C are missing. So any number of combination I can take here and I can form the set of. It is nothing but your set of strings given by this regular expression, right? And this set of strings belongs to your language. And which is the language? This particular language which is given in the question. The language consists of such a string, or every string have any number of A followed by any number of B followed by any number of C. Very simple. There is no any difficulty in this particular writing regular expression. Next one is write the regular expression for the language in which every string will have at least one A followed by at least one B followed by at least one C. Same that just now we have discussed. At least one means yes, definitely there is one A compulsory, B, one B is there, and compulsory C is there. Means in this case, this epsilon, this empty string will not appear here, right? But excluding all this, so you can have A, you can have B, you can have C. A single occurrence of A, B, C is possible here, or it is compulsory there, right? Next one is write the regular expressions for the language in which every string will have third character from the right end of the string is always A. So we have to write the expression for this for the language, and this particular language consists of such a set of strings. And now the strings will have third character from the right end of the string is always a. So third character means, suppose if I write here a, B, B. For example, so right hand side means this is the first character, this is the second character, and this is the third character. So my format or the string format must, all string format must be like this. And here, so any number of A and B, any number of A and B. So at any number of A and B are here. So here you have here you have B or A, or here also at the last end you have one first, this is second, and this is the third last. So I can say this is the last letter on the, or of the first letter on the right hand side, second letter on the right hand side, and the third letter on the right hand side. So I can write like this: any number of A's and B dot A. So this A position is fixed. This is the third position, which is given in the example, third character from the right side. So third character from the right hand side. So this is nothing but my right hand side. Either A or B, either A or B. I can have here A dot either A, or it can be B, or here also A or B, and here any number of A and B. So here you can have 2A, 3A, 4A, and A 2A dot 4A. Any combination of A and B is possible. Dot A, and this is the second last character, and this is nothing but the last character. But the third character is always A. Third character is always A. So the expression is written like this. See here. So the expression is written in this way: A plus B. So any number of A's and B. What is the meaning of this? Any number of A means A plus B raised to star dot this A as it is, either A or B. The what is the which is the operator used for either or plus operator is used here, or that is nothing but either A or B. A or B is possible. Dot compulsory again, this dot either, because this is the second one, this is the third one, and the first last is nothing but your A plus A or B, either A or B. So this is the first one. So for starting from the right hand side, your third letter is always A, right? So in this way, you have to understand the statement first, and then you have to write the correct regular expression. And it is very simple. Once you practice it, then it becomes very easy. Next one, write the regular expressions for the language in which every string will have at least two B's over input sigma equal to A comma B. We are reading this one. Write the regular expression for the language in which every string will have at least 2B over input sigma equal to A comma B. So how to write it? So regular expression. So 2B means, yes, any number of A or B dot B. This B is compulsory. Dot any number of B, any number of A or B dot B. This B is again compulsory, and at the end any number of A and B. Right? This is the simple one. So we'll have at least two B's. At least 2B means, yes, at least 2 means minimum 2B must be there in the string. More, you can have more than 3, 4, 5, 6, 7, any number of B it is possible in the string, but minimum 2B must be there. So I can have this particular string. So if I write a string like this, A, so minimum 2B means this is our first string. BB means 0 occurrence of this, 0 occurrence of this, and 0 occurrence of AB. So I can have A, B, then I can have A, B, A. So this may be possible, or any combinations of this particular thing is possible, provided these two B's are compulsory here, because we have exclusively mentioned here B. This is the compulsory B and this is compulsory B, but here A plus B, you can have any number of A plus B. Here also any number of A plus B, and here also any number of A and B are possible, right? Next one, write the regular expression for the language in which every string will have exactly 2B. Exactly 2B means what? Exactly minimum. Exactly 2 means only 2B. Exactly 2B means this is different than the previous one. This and these are the different one. Exactly 2B means, yes, this is the one and this is the second. Only 2B's must be there. Only 2B must be there. In this case, what happens? You have minimum 2B means here a number of B is minimum 2, and it can more any number, because here A plus B. You can have B, 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 you can have triple B, 4 times B, 5 times B, it is possible. But in this case, you have A star dot B dot A star dot B dot A star. Means A star means here 0 or 1 occurrences of A. Here also 0, 1 or more occurrences of A. Here also 0 or 1, 0 or more occurrences of A is possible. But B are only 2 here. So B are 2 as per the given problem. So exactly 2B. Yes, here exactly 2B. So you can have A, B, A, B, A. This is the string. So exactly 2B are there, or you can have BB. zero occurrences, all three A are zero here. Or you can have A, B. B is also possible because these two A are, we make it zero. So A, B, B is there. But so still you have exactly two B's are remaining in your string. Getting this point. So this is the way how we have to write down the regular expression, right? Write the regular expression for the language accepts all strings of A and B containing at least one combination of double letters. At least one combination of double letters means you have the two input symbols. You have the two input symbols like AA or you have BB. So at least one combination of AA must be there or BB must be there. Both may not be there, but at least both may or may not be there. But at least double A or double B must be there. So double letters are AABB. So see here, A plus B bracket raised to star dot AA plus BB means either this is nothing but your or, either double A is there or double B is there, dot A plus B. This is nothing but again or. So you can have AABB is also possible, or you can have BB0 and double A is there, or AA0 double B is possible. Getting this point. So and any number of A and B here at the start and at the end also any number of A and B are possible in this particular state, right? So let us go to the next slide. Write the regular expressions for the language which accepts all strings which begin or end with either 0, 0 or 1, 1. So here two or are there. See here, see very carefully. So we have to write the regular expression for the language which accept the strings which begin or end with either 0, 0 or 1, 1. So for this begin and end, this is two conditions, and 0, 0 or double 1, these are the two conditions. So total four conditions we have to consider here. So see how. So let R1 equal to string begin with. So capital R, this is nothing but the regular expression. Consider capital R1, which consists of the string begin with 0, 0 or 1, 1. So we'll take first this one, begin one. So either the string begin with 0, 0 or double 0 or double 1. Then R2 string end with 0, 0 or 1, 1. So this is the for this end 0, 0 or 1, 1 because these are the four conditions. So take first regular expression R1, then next take regular expression R2, right? So what will be our regular expression? So R1 is nothing but your 0, 0 plus 1, 1, either the dot any number of, so start begin with 0, 0 or 1, 1. Begin with 0, 0 or 1, 1 means into the bracket 0, 0 plus 1, 1 means it is or, either it will start with 0, 0 or it will start with 1, 1 dot any number of 0, 1. So this is nothing but our string. And R2 so this way this is nothing but your 0, 0 plus 0, 1, 1 dot 0 plus 1. So any number of zeros and 1 is nothing but your 0 plus 1 bracket is to start any number of zeros and 1. And R2 is any number of zeros and 1. Take this first, and at the end you have 0, 0 or means string end with either 0, 0 or 1, 1, either 0, 0 or 1, 1. So I can have 0 plus 1 bracket is to star dot 0, 0, 0 into bracket 0, 0 plus double 1. Getting this point. So this is the case. So first define a regular expression R1. So R1 consists of a string that begin with 0, 0 or 1, 1. Now take another regular expression R2 that this contains the strings that end with double 0 or double 1. And so R1 can be written in the form of regular expression like this: 0, 0 or 1, 1 dot any number of zeros and 1, right? And R2 can have any number of zeros and 1 dot 0, 0 plus 1, 1. So meaning is that R1 I can write here 0, 0 plus 1 dot 0 plus 1 bracket raised to star, means any combination of 0, 1 is possible here. And in this case 0 plus 1 raised to 0 plus 1 bracket raised to star dot 0, 0, 1, 1 means any combination of 0, 1, but it must end with either 0, 0 or either 1, 1. So I can have R1 plus R2, I can combine it. So R1 plus R2 is nothing but this. So this is nothing but my R1, this is nothing but my R2, that gives me the required regular expression, that is the required regular expression, that is R equal to, this is R1 plus R2. So R1 plus R2, right? So this is our final answer. This is nothing but the regular expression, required regulation for the language that accept all strings which begin or end with 0, 0 or 1, 1. Getting this point? Okay. Write the regular expression for the language. See here, the first sub question is given. We have to write the regular expressions for the language containing all strings ending with B. So the language which consists of such a strings, in this particular language, there are such a strings are possible that always end with single B, that always end with single B. So it is very simple. I can write regular expression R equal to A plus B bracket raised to star closure dot B means the whatever be the string is there that always end with B character or B alphabet, right? The second question or the second sub question is containing all, write the regular expression for the language containing all string that end with BA. Again, the same one, that is R equal to A plus B bracket raised to star dot BA means the string always end with this BA, two letters, right? Then containing all strings ending neither with B nor with B. See here. So we have to write the regular expression for such a string that neither end with B nor end with BA. Means these two conditions we have to make a negation of this. We have to make the negation of this. So I can write like this. See here. So meaning is that there must not be B. So instead of B, we have taken here A, and it must not end with BA. That's why it is taken as AA. So there should not be any BA combination, and B combinations are strictly avoided here. So A plus B raised to star, it remains as it is, dot AA plus A raised to star. Means it will going to avoid you the ending with B and ending with BA. Getting this point? Write the regular expressions for the language. First sub question containing all strings having exactly two zeros. So having exactly 2 0 means the same already we have seen it. This A 1 raised to star dot 0 dot 1 dot 0 dot 1 raised to star. So it contains exactly 2 0. Here I think on 1 there must be star. So it must be like this: A 1 star dot 0 dot 1 raised to star dot 0 dot 1 raised to star, right? So meaning is that it must contain the exactly 2 zeros, right? Then containing all strings having at least 2 zeros. At least 2 0 means minimum 2 or more than 2 are also possible. So you can have 0 plus 1. So same you can have 0 plus 1 means either 0 or 1 bracket raised to star dot 0. 0 plus 1 bracket raised to star dot 0 into bracket 0 plus 1 bracket raised to star. Any combination of 0 1 are possible. So here number of 0 are more than 2, 3 4, any numbers of 0 it is possible. That's why at least 2 0 means minimum 2 are there. And exactly 2 means what? Exactly 2 0, not more than 2. 2 number is fixed here. 0 2 are the sufficient, not required more than 2. That's why it is exactly 2. And at least 2 means minimum 2 zeros are possible. More number, it can have any number. Containing all strings that does not end with 0 1. That does not end with 0 1. So does not end with 0 1. 0 1 means it must end with 0 0, or either it end with 1 1 or either end with 0 1 0. So this is the possibility, right? Your string that does not end with 0 0. So which are the different possibility that the string must end? So it does not contain the 0 1 means either it end with 0 0 or it end with 1 1 or it end with 1 0. So I can have the combination like this. So means it may end with 0 0 or it may end with 1 1 or it may end with 1 0, but not with 0 1. We have to avoid this thing. We have to avoid the 0 1 combination at the end. So two letters at the end must not be 0 1 always. So for that, so two letter must be either 0 0 or they may be 1 1 or they may be 1 0, but it will be not 0 1 in any case. So expression is written like this: 0 plus 1 bracket raised to star. So any combination of 0 plus 1 is possible into the bracket 0 0. The means this particular string end with 0 0, or you are taking here 1 1, or you are taking here 1 0, right? So this string, it may have this 0 0 at the end, or it may have 1 1 at the end, or it may have 1 0 at the end, but not in any case it must not end with 0 1, right? So this is the way. So in this this is the way how we are solving the examples to write the regular expression for the given language. So language is given and we have to write the regular expression for the language. Now the next topic is given. Second topic is now that construction of regular expression. This is some different format of the question. So write the regular expression. Some one can say that the the questions which we have discussed, they are different as compared to the questions which we are now going to discuss here. So see here, for sigma equal to 0 comma 1, so language, so format of the question is somewhat different here, but the rest of the thing is simple or the same one. For sigma equal to 0 comma 1 means for the input symbol sigma equal to 0 comma 1, such that L of R means language of R, such that in the curly bracket W means it is a word which is belongs to sigma raised to star S string, such that W means this particular word or the string, this particular string has at least one pair of consecutive zero. At least one pair of consecutive zero means the same way. Only the thing is that the question format is different. In earlier examples, earlier 17 examples, the straight away questions are asked in the English language ki write a regular expression for the language having strings such and such a way. But here the same way, but the question format asked in some mathematical format. So we have to write the regular expression where input alphabets are 0, 1, and we have the language which consists of words belongs to the input, belongs to this particular input strings, that is a star property, such that W means this strings consist of these words, string consists of these particular characters, such that each string has at least one pair of consecutive zeros. Each string contains one pair of consecutive zero. So means I can write here R equal to 0 plus 1 raised to star means any number of 0 and 1 dot double 0 dot 0 plus 1 raised to star. So at least one pair of consecutive 0 means the string must contain double 0, and to this side and to this side any number of zeros and 1 are possible. Second one is that for write a regular expression for the language such that for sigma equal to 0 comma 1, such that language L equal to W belongs to 0 comma 1 star, such that W that is has no pair of consecutive 0. It has no pair of consecutive 0, and the expression is written like R equal to 0 plus epsilon. 0 plus epsilon means either 0 or epsilon dot into bracket 1 plus 1 0 raised to star, means this particular regular expression gives us a string which does not contain the consecutive zeros, which does not contain the consecutive zero. If you want it, you can expand this. You can expand this. So I can have 0, then I can have 1. So if I write like this 0 1 1 0, so no consecutive 0 we will find here. So we write it. I can have 0, or I can have 1. I can have 1 0. I can have 1 0, 0 1 1 0, or I can also have 1 1 0. But you will not find the two consecutive zeros here. So this is the regular expression. We have to check whether we have written it correctly or not. We can check it. Then third one is that for sigma equal to a comma b such that language consists of, see here, so language consists of a raised to n, b raised to m, a raised to n and b raised to m, where n is greater or equal to 4 and m is less than or equal to 3. So n greater or equal to 4, so a raised to n, right, and n is always greater or equal to 4 and m is less than or equal to 3, and we have b, there are letters or there are strings. So we can read like this: there are string in this particular language L in such a way that number of A must be raised to n and number of B raised to m. And what is the value of n? N is nothing but always greater or equal to 4. So minimum value of n is equal to 4 and minimum value of n is equal to 3. So strings in that particular language consist of A and B, and their numbers are given here 4. So n is always greater than 4, equal to 4, or m is less than or equal to 3. So I can write here 4 times a. So minimum 4a are there, and that is nothing but plus dot b into bracket epsilon plus b plus bb, means less than b. M is always less than or equal to 3. Less than or equal to 3 means I can have one occurrence of b, I can have two occurrences of b, or I can have b is compulsory here and 3 occurrences of b are possible. So that's why, so regular expression is written like this: r equal to 4 times a raised to plus, means positive closure for this, means at least one occurrence of a is there, dot b, this b is compulsory, and here epsilon means one occurrence of b. If it is a b, then two occurrences of, then if it is a 3, then it is a 3 occurrences, and m is always we are maintaining the number, that is m is equal to, m is less than or equal to 3, right, for the b, for symbol b, and n is greater than or equal to 4 for a, for input a, right. Consider the next one. For a sigma equal to 0 comma 1 such that language consists of all strings containing even number of zeros. So we have to write down the expression, regular expression for the language L, such that the strings in this particular language L, having the strings containing even number of zeros. Even number of zero means either it has zero or you can have four number of zeros. So like this way, even number of zeros are there. So how to write the regular expression? So see here. So 2. So 1 raised to star dot 0 dot 1 raised to star dot 0 dot 1 raised to star bracket raised to star plus 1 means either this or this. Means you always have, means you can have the minimum string, you can have 0 0 or it can have 0 0 1, or right. So these are the, means even number of zeros, you can have the regular expression like this. Getting this point? 1 raised to star dot 0 dot 1 raised to star dot 0 dot 1 raised to star bracket raised to star plus 1. Getting this point? So this is the way how we are writing the regular expression for the given language. Regular expression for the language which is asked in the example. Next one. Now the exactly reverse, means the regular expressions are given to you, and we have to write the description of the regular expression, or we have to write in more precisely, we have to write the language. We have to write the language for that regular expression. So far the examples we have discussed there, what we have written, we are being given with a language key. The language is such that there are strings containing any number of a and b. The English statements of the language are given, and we are used to write down the expression a plus b bracket to start, right? But here we have to go exactly opposite, means vice versa approach is there. Expression is given, regular expression, and it is asked to write down the English language statement. So describe in English language for the following regular expressions. So regular expression is given a plus b bracket raised to star dot a. So if it is not mentioned here exclusively, yesterday also I have told you that if it is not mentioned, you have to assume it is a dot operator always, because it is nothing but a multiplication or and operator. So a plus b dot a, and this a is compulsory. A plus b means any occurrences of a plus a b here, any number of occurrences of a plus b here, and a is compulsory. One a is compulsory there. So how to write this? So the language. So I write here, it is nothing but the language that accepts the string that contains at least single a. At least single a must be there in this particular the language given by this particular regular expression. The language which is given by this particular regular expression, right? And this you can write when you practice it, you will able to write this thing, right? So there is no any difficulty while writing also from regular expression the given language. Now the next regular expression is 0 1 raised to star dot 0, then 1 is there. So the language accept the strings made up of zeros and 1. Okay, no problem. That ends with 1 because this 1 is compulsory. That ends with 1, and between two zeros there are any number of 1. So this is the description of the language. So I have written the description like this. So this is the language. This regular expression gives me the language that accept the strings made up of zeros and 1. No doubt it is a made up of 0 and 1. That ends with 1. So this is the important part, that always ends with 1. And in between two zero, in between this 0 and this 0, there may be any combination of 1. There may be 0 1, or there may be 1 1, or there may be 2 1. It may be possible. So you can write, and it is very simple. You can describe for what this regular expression is written, for which language or this regular expression is written, right? Next one, a into bracket a plus b bracket raised to star dot bb. Again, it is a very simple one. So the language accept the strings made up of a and b that starts with a, and ends with bb, and it can have any combination of a and b in between a and b, right? Then next is a plus b bracket raised to star. So the a, now this is or a plus b and bracket raised to star means any combination of any numbers of a or any number of ab's are possible here. So how to write the language? The language, the regular expression gives the language that accepts the strings made up of a and b, okay, that starts with a, and b is always preceded by a. So that always starts with a. No doubt if it is a is there, then it is also starts with a, and if it is a string ab, then also it starts with a, and a is always preceded by, sorry, B is always preceded by A, means there is always this string must be there, AB, AB. So B is always preceded by the letter A, or the that character A, right? Next one. A star dot AB star dot AB star out of the bracket plus B raised to star. We have to write the language for this particular given regular expression. So I can write the language that accept the string that contain either at least two A's. So what I observe from the regular expression, that this A is compulsory and this occurrence of this A is compulsory, where this is can have any number of occurrences, this B and this B have any number of occurrences, and this B also has any number of occurrences. So I can have the language that accepts the string that contains either at least 2A or any number of B, or any number of B. It is possible because here it is or any number of B. So B can be 0B, or there can be 1, there can be double B, there can be any number of B's are possible. So from the regular expression I can observe, so what the things I can observe, I have to write it in the English language. The next example, A raised to plus dot B raised to star dot C raised to plus. So the language that accept the string that contains at least one A. So at least one A followed by any number of B. So this significance of this B star is nothing but followed by any number of B's followed by at least one C, at least one C. It is very simple, right? So this regular expression defines the language that accept the strings that contains at least one A. Yes, definitely, because it is A raised to, it is a positive closure, followed by any number of B because it is a clean closure of the star closure, followed by one C, that is nothing but your at least one C, that is nothing but your positive closure of C, right? Next example, 0 raised to star into bracket 0 star dot 1 dot 0 raised to star dot 1 out of bracket raised to star dot 0 raised to star. So this one is compulsory and this one is compulsory, and any number of occurrences of this 0 0 and 0. So for this I can write the language accept the string that contains even number of ones. Yes, even number of ones or 2A or 2 ones are compulsory, and any number of 0 and any number of zeros are possible in such type of regular expression, right? Okay, so in this today's session, what we have discussed or what we have learned is the construction of a regular expression. So we have seen so many examples to construct or to write the regular expression for the given language, that is nothing but L. And also the reverse procedure also we have seen the construction of the language or write the language from the given regular expression. Regular expression is given 0 A raised to star B raised to star. What is the language? And the regular expression, that is nothing but your construction of language from the regular expression. These two important topics we have covered in this today's session, right? So the course outcome attainment is nothing but to write mathematical expressions for the formal languages. Mathematical expression is nothing but your regular expressions, right? Okay, so these are the references. So let us stop here for the today's session.